When we look up at the night sky, space appears frozen, serene, a silent abyss stretching out into infinity. We feel safe on our blue world, isolated from the dark void by a thin layer of atmosphere. But this absolute silence is the greatest illusion in the universe. Our planet is not a stationary observer. Earth is a massive spaceship hurtling through an icy vacuum at an astonishing speed of over 100,000 kilometers per hour. And on this orbital highway, we are far from alone. Right now, millions of fragments of primordial matter are roaming the vastness of the solar system. These are the ancient leftovers from the birth of the planets. From tiny, microscopic grains of sand to massive mountains of iron and rock the size of a metropolis. Every single day, Earth's gravity pulls in about 100 tons of cosmic dust and small meteoroids. They burn up in the upper atmosphere, painting streaks of light across the darkness. We romantically call them shooting stars. We close our eyes and make wishes. But the romance ends when you realize the scale of the threat. What happens when a rock the size of a mountain, moving at 50 times the speed of a sniper bullet, emerges from the darkness? Welcome to the cosmic shooting gallery. To understand the future, we must look at the scars of the past. Our planet's history is literally carved by violent impacts. The most infamous event occurred 66 million years ago. The apex predators of the time, the dinosaurs, ruled a lush, vibrant world. That era ended in a single afternoon. A rock 10 kilometers across slammed into the shallow waters of the Yucatan Peninsula. The impact unleashed the energy of billions of nuclear bombs. It created mega tsunamis, ignited global wildfires, and threw so much ash into the atmosphere that it blocked out the sun for years. You might think such catastrophic events are buried deep in prehistory, but the danger is much closer to home. On a summer morning in 1908, a blinding light tore through the sky over Siberia. The Tunguska event. An asteroid exploded mid-air, flattening over 2,000 square kilometers of dense forest. Millions of trees were snapped like matchsticks. If that exact same object had entered the atmosphere just a few hours later, the rotation of the Earth would have placed it directly over a major European capital. The destruction would have altered the course of human history. And we received another brutal wake-up call in 2013. Without any warning from our most advanced observatories, the Chelyabinsk meteor exploded in the morning sky. The invisible shockwave blew out windows across the entire region, injuring over 1,000 people. The cosmos proved once again, it does not negotiate, and it does not warn. Where do these cosmic assassins come from? The vast majority reside in the main asteroid belt, a colossal, chaotic ring of debris orbiting between Mars and Jupiter. It is a cosmic junkyard, containing millions of rocks that never managed to form into a proper planet. In this crowded orbital zone, violence is the norm. Asteroids constantly collide, shattering each other into smaller fragments. But these fragments don't always stay in the belt. The solar system is ruled by gravity, and Jupiter, the giant of our system, acts as a turbulent gravitational engine. Its immense mass can tug at these rocks, pulling them out of their stable orbits. Like a giant cosmic slingshot, Jupiter flings these rogue asteroids inward, sending them on a collision course with the inner planets. These are known as near-Earth objects. They are silent wanderers whose orbits cross our own. Astronomers track tens of thousands of them, but calculating their exact path decades into the future is an incredibly complex mathematical challenge. The most terrifying threats are not the ones we track, but the ones we cannot see. Our ground-based telescopes constantly scan the night sky. However, they have a massive vulnerability. Any object approaching Earth from the direction of the sun is completely hidden by the star's blinding glare. They are invisible until they are right on top of us. That is exactly what happened in Chelyabinsk. To solve this, scientists are developing space-based infrared telescopes designed to look for the faint heat signatures of these dark rocks against the freezing backdrop of space. But even the objects we do see bring enough anxiety. Consider the asteroid named Apophis, named after the ancient Egyptian god of chaos. This colossal rock, spanning over 300 meters in diameter, is heading our way. On Friday the 13th, April 2029, Apophis will pass so close to Earth that it will slide beneath the orbits of our highest communication satellites. It will be visible to the naked eye. While calculations confirm it will safely miss us this time, the immense gravity of Earth will bend the asteroid's path. This interaction is a cosmic wildcard. If Apophis passes through a specific narrow region of space known as a gravitational keyhole, its altered orbit could ensure a direct impact with Earth on its next return. We are constantly updating the math, hoping the numbers stay in our favor. But humanity has decided not to rely solely on hope or mathematics. For the first time in the history of our planet, the target can fight back. We are no longer waiting passively for the sky to fall. Humanity has officially entered the era of planetary defense. The strategy is brilliantly simple, but incredibly difficult to execute. It's called the kinetic impactor method. Recently, the Double Asteroid Redirection Test, or the DART mission, proved it could work. A spacecraft intentionally crashed into a small asteroid at unimaginable speed. The goal wasn't to destroy the rock like in a Hollywood movie, but to nudge it. By altering an asteroid's velocity by just a fraction of a millimeter per second years in advance, the sheer vastness of space magnifies that tiny shift. Over time, that slight change in trajectory means the asteroid will arrive at the intersection point long after Earth has already moved safely away. Scientists are also exploring alternative methods. The gravity tractor concept involves flying a massive spacecraft perfectly parallel to an asteroid for months or years. The subtle gravitational pull of the spacecraft itself would slowly, gently tow the dangerous rock onto a safe path. The challenge ahead is monumental. It requires global cooperation, immense funding, and technology pushed to its absolute limits. Telescopes around the world stand as silent sentinels, watching the dark shores of the cosmic ocean. The dinosaurs perished because they were merely passengers on this planet. They didn't have a space program. We do. The cosmic roulette wheel is still spinning, But now, humanity holds the tools to finally take control of the game. Our survival is no longer just a matter of chance. It is a matter of choice.